We're going to take a look at some more permutations, and this problem and the next problem are done exactly the same way, and we're going to use the math key to be able to do this. You'll find these problems in the book on chapter 3.4 if you want to find them and know how to work them out by hand. But this one is finding n when you're given a certain number of objects and you want to take them a certain number at the time. N is the objects you're given, R is the objects you're going to take, how many at the time. And here it says find the number of ways of forming 3-digit codes in which no digit is repeated. So I want to know numbers. So I've got 10 digits, the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. I want to use them 3 at the time, so I'm going to do the permutation of 10 objects taken 3 at the time. So I'm going to pull the calculator up so you can take a look at that. So I would need to type in 10 first, because you always have to type that number in before you go to the math key. And I'm going to go over to PRB, which is probability, and I'm going down to permutation, which is number 2, and I'm going to press enter. And then I'm going to press 3 because that's how many objects I'm taking at the time. I have 10 objects taken 3 at the time, and there are 720 ways to do this. Now I'm going to go back to the screen again, and we're going to look at another problem. This one says I have 43 race cars that started the 2007 Daytona 500. How many ways can the cars finish first, second, and third? So I have 43 cars taken 3 at the time. So let's go back to the calculator, and I would again type in 43. Then I would go to the math key, over to PRB, down to permutation, and I'm going to take those 3 at the time. And order does matter. Excuse me, I put the wrong thing there. So let me back up. And I'm going to go 43 and math over to probability and down to permutation. Sometimes when you're doing this with the calculator and the mouse, it will move down faster than you'll click and it doesn't move. So then you'll click again and it goes to something else. So there's enter, and I'm taking 3 at the time. So I'm going to press enter, and there's 74,046 ways these cars could win. These are permutations because order matters. I'll send a video later about combinations, and that's when the order does not matter, that you use combinations. So I'm going back now to another type of permutation, and this one is called distinguishable permutations. A building contractor is planning to develop a subdivision. The subdivision is to consist of 6 one-story houses, 4 two-story houses, and 2 split-level houses. We've all been in subdivisions where there are houses that are built using the same plan. That's what's happened here. And how many distinguishable ways can the houses be arranged? And now this can be done using the calculator, but you're going to use the factorial key, not permutations, and you're going to use parentheses. So here's what it's going to look like. You have a total of 12 houses, and there are 3 different types of houses to be built. One-story houses, two-story houses, and split-level houses. Those are the 3 types. The total always goes in the numerator, and the 3 types go in the denominator. So I'm going to show you how to do this on the calculator. You're going to press 12, math, over to probability, and down to factorial. Even though factorial is a type of permutation, it has to be done this way. And we're going to press enter, and then we're going to put the divided by sign, and then we're going to do 6, and we need parentheses. Let me back up. Parentheses, 6, math, over to probability, down to factorial, press enter, and then we want 4, over to probability, down to factorial, and then we want 2, same thing, math, over to probability, down to factorial, and then we're going to close our parentheses and hit enter, and there's your